We are talking discrete distribution. Last class we discussed binomial. Today we are going to discuss Poisson distribution. Let's see what it looks like. Here's an example. If you count number of calls made to an office between 9 and 10 a.m. daily, and just count number of calls and then accumulate it daily and draw frequency table, what it look like. How about the number of one-day traffic accident occurring at a certain intersection? How about the number of defective spot per unit area of the fabric? What is the characteristic? It look like binomial. Calls come or not, or traffic accident occur or not. Yes, it look like binomial, but the characteristic is the probability is very low. The probability of success is very low. The traffic accident usually 0 or 1 at most. Or rarely it maybe have 2 like that. We are curious about that kind of probability. We call this is Poisson random variable, and corresponding distribution is Poisson distribution. Well, there are some more examples. Demand for a product sold every day at a certain store. Well, it depends on product, but most of them you sell only 0, 1, 2, like that. Then it belongs to this random variable. And then the number of typos that occur on each page is to be low, right? We already discussed the number of accidents. It's a similar thing in a factory. It is nearly 0, almost every day. How about the number of defective per unit length of cloth? Well, in a cloth, if there are many defective, you cannot sell it. It's to be near 0. All that kind of thing belongs to Poisson distribution. Here's a distribution function. Okay. Here we call lambda is average number of success. Average number of car accident, average number of typo, like that. Then the probability can be described in this manner. How it come, that is beyond of your level. You need to take mathematical statistics. Here just please accept, and the distribution function look like this. If I say we can derive this kind of function from binomial distribution. Expectation is lambda because we use the lambda as the average number of success. And somehow if you calculate the variance, it is also lambda. Here are some distribution you can practice with eStat. Let's practice right now. Go to eStat, www.eStat.me, click eStat.u, will give you many distribution. We are curious about the Poisson. Well, depending on lambda, we call this is a parameter of Poisson. You can experiment many kind of Poisson distribution. If it is increased as binomial, it looks like normal, but still a little skewed. If you want to calculate the probability table, well, you click this button, and they're gonna generate you this table. Let's go back to this slide. There's the example. Assume that cars per minute arriving at the highway toll gate during rush hour is the Poisson. And average of 5 cars per 1 minute. That means lambda in our notation is 5. One day if you observe the toll gate for 1 minute, they are asking this probability. none of the cars will arrive. What is the probability of 5 cars, more than 2 cars? You can calculate it here. I mean, you may use this mathematical formula. If you understand how to calculate it, you may use that. I mean, we have lambda 5. That means you need to switch it. This is 5. And then just click this button will give you probability. Maybe you can see the probability, or click this button will give you probability like this. Then you can answer everything. X equals 0 is 0.0067. X equals 5 is like this. Greater than 2 imply this probability. Right? Greater than include, well, maybe greater than imply, maybe you can consider this probability is like this. Okay, similarly, suppose lambda equal 2.5, you can answer this probability. Just switch this number, lambda equal 2.5, and clicking execute button, they're gonna generate a probability, or you can click Poisson probability table to answer this question. Okay, maybe I don't need to review that, but just once you need to practice this mathematical formula, just to plug in numbers in case of probability x equals 5, plug in numbers 5 here. Okay, that's all for today. Next lecture, we'll discuss the discrete distribution.